Very good morning. We are continuing with multivariate linear regression, estimation of parameters. Today we will continue with estimation of parameters with an example, and then we will show you how to estimate the error terms. Let us see the next.
Now we will continue multivariate linear regression. First we will discuss about estimation of parameters. So last class what we have seen that y is function of x in terms of regression coefficient beta as well as error term. So here the matrix looks like this. Y is n cross q matrix. Our x is n cross p plus 1 matrix, and beta definitely should be p plus 1 cross q matrix, and our error term is also n plus q matrix. So we also have discussed the relationship with MBLR, that is multivariate linear regression vis-a-vis multiple linear regression, and we have also seen that if we go for multiple linear regression of individual y variables and then estimate the parameters, the estimates like beta 1 cap, beta 2 cap, beta your q cap will be exactly same if we estimate jointly using the multivariate linear regression formulation. The formulation remains same. Beta cap is x transpose x inverse x transpose y. So now we will discuss that with an example, that how we can estimate this beta cap. So let us take a very simple small example where y is 3 cross 2, that means n is 3 observation, q is 2, so q is 2. So on 2 dependent variables, the values are 10, 12, 11, 100, 110, 105. So let us consider two independent variables also, So I can say that p equal to 2. In that case, the data matrix may be like this, where 9, 8, 7, 62, 58 and 64. These are nothing but the first 3 observations for the Statistical example we have given earlier. So what we require to do now? We require to find out the design matrix X, which will be n cross p plus 1. Here n is 3 cross p plus 1, that means 3. So this one is 1 1 1, that is for the constant term, then 9 8 7, 62, 58 and 64. So what is our beta estimate? Beta estimate is beta cap equal to x transpose x inverse x transpose y. Our step 1, compute x transpose x. So if we write like this, then x transpose x is 1 1 1, that is basically the transpose of this matrix, 9 8 7, then 62, 58 and 64. This is your x transpose. Now what is our X matrix? X matrix is 1, 1, 1, 9, 8, 7, 62, 58 and 64. If you multiply this, what you will get? What will be your multiplication? 1 into 1 plus 1 into 1 plus 1 into 1. So, this will be 3. Similarly, 1 1 into 9 in 8 7. So, 9 plus 8 plus 7, this will be 24. Similarly, third one is 62 plus 58 plus 64, this will be 184. Now, for you consider the next row, 9 into 1 plus 8 into 1 plus 7 into 1, which is nothing but 24. Then 9 into 9 plus 8 into 8 plus 7 into 7, the square term. So, it will become 194. Then 9 into 62, 8 into 58 plus 7 into 64, this will become 1470. Then it will be asymmetric matrix. So, symmetric and square. So, this 184 will come here, 1470 will come here, and the remaining term will be 62 square plus 58 square plus 64 square. So, this total quantity will be 11304. Okay. So, this is what is our X transpose X. Then you have to compute X transpose X inverse. This is our step 2. Step 2 says X transpose X inverse. This will be 1 by determinant of X transpose X adjoint of definitely X transpose X. So, ultimately the resultant quantity you will find out, it will be, if you use any, suppose you use Excel, I have used Excel, and then the value what I got, this value is for this data set, that is 320.76 minus 8.16 minus 4.16. As symmetric matrix, this will be 1 minus 1.8.16. Then in this one is 0.56, this one is 0.06. So, this value will repeat here. So, minus 4.16, this value will repeat here 0.06, then the last term is your 0.06 also. This is what is inverse, X transpose X inverse. Your step 3, you compute X transpose Y. So, if you write down X transpose Y 1 1 1, then 9 8 7, 62 58 64, then Y values are 10, 12, 11, 100, 110, 105. Again, if you go for matrix multiplication of these two, and if you use Excel, what you will be getting? You will be getting X transpose Y equal to 33, 315, 263, 2515, 2020, 19,300. So, with respect to this problem, that means what we are discussing now, we are discussing that we are given this problem that Y is 3 cross 2 matrix, X is again 3 cross 2 matrix from the data point of view, but from design matrix point of view, it is 3 cross 3 matrix, and we are using this beta cap equal to X transpose X inverse X transpose Y, that is what is the estimation formula for beta. So, our step 1 comprises X transpose X and we got this value. Then step 2, we want the inverse of this x transpose x, this value is like this, and your step 3 is you have to find out x transpose y, because you see that x transpose is 3 cross 3 and y is 3 cross 2, so you will be getting a resultant matrix of 3 cross 2. So this is x transpose y. Then your step 4 is what is required, you have to multiply that 2 your step 4, that x transpose x inverse x transpose y, this two matrix you multiply, and then what is our x transpose x inverse? X transpose x inverse is we have found out here. So your x transpose x inverse is, you write down, that is 320.76 minus 8.16 minus 4.16 minus 8.16, 0.56, 0.06, then minus 4.16, 0.06, 0.06. Then what is our x transpose y? So our x transpose y is 33, 263, 2020, 315, 2515, 19,300. This is the resultant this 3 cross 3, 3 cross 2, we will be getting a 3 cross 2 matrix, and that value, if you again use a software or you go by MATLAB or Excel, what you will get this multiplication of these two will give you 35.80 minus 0.80 minus 0.30, then here it is 229, then minus 4.00, then minus 1.50. This is what is your beta matrix. This is what is your beta 1, that if I say that beta 1 cap and beta 2 cap, which is nothing but your beta 1 cap 0, beta 1 1, so beta 1 2, then beta 2 0, beta 2 0, 2 is affected by 1, 2 1, and beta 2 is affected by 2. Correct. So what you have got then? You got two equation. If I go by the logic that y is x beta plus epsilon, where y is here in this case y1 y2, and your here x is here x1 and x2, and beta is here that beta 1 0, beta 1 1 cap, beta 1 2 cap, then beta 2 0, beta 2 1 cap, and beta 2 2 cap. So if we write like this, this is basically 2 cross 1, then this one is 3 cross 2. So in this manner it will not work. What is required? So okay, plus epsilon, that will be there. So you have to think from matrix that compatibility in multiplication. Matrix multiplication. Okay. So what we will do then? We will not write like this. Straight cut, if I write y1 equal to beta 1 0 plus beta 1 0 cap, beta 1 1 x1, then beta 1 2 x2 plus epsilon 1, this one epsilon 1 and epsilon 2. Then your y2 is beta 2 0 cap, beta 2 is affected by 1 x1, beta 2 is affected by 2 x2 plus epsilon 2. Okay. So that means if you write like this, beta this row wise and then this side x1 and x2, so this into this plus this into this, so that way it will get. Okay. So here I told you that matrix compatibility is required, but this is the resultant equation. So in our case you can write that y1 equal to 35.80, then minus 0.80 x1 minus 0.30 x2 plus epsilon 1, and your y2 is 229 minus 4.00 x1 minus 1.50 x2 plus epsilon 2. This is what is the that example data. Actually what I have done, I have taken this profit, sales, then your absenteeism and breakdown hours from the Statistical data, and we have taken only first 3 observation 1, 2, 3 just to go for computation, because you will be applying software. So you require to use more data points, not 3 data points. There will be lot of problem with small data set, I will show you. So if this is the case, then this y1 is nothing but profit, x1 is nothing but your absenteeism, x2 is nothing but your breakdown hours, y2 is sales, then this one is again absenteeism, and this one is breakdown hours. So in multiple regression, although this y side y1 y2 their profit and sale different variable, but you see x side they will be same variable for both the equations. Okay. So if absenteeism increases, profit will go down, if breakdown hour increases, profit will go down, if absenteeism increases, sales also will go down, if breakdown hour increases, this also go down. So that means the relationship will be negative, and that is coming from this example also. But as we have taken only a small amount of data set, it may so happen that it will give different results, means conceptually just opposite. So but don't worry, this type of situation may occur because of your problem in collecting data, primarily the study design problem, that you have to take care. Now once you have the equation that y cap equal to x beta cap, this is what is your fitted values. So your original observations are y equal to x beta, if we write like this, plus epsilon cap, because from parameter estimation point of view you have to estimate this epsilon also. Okay. So then from these two we can write epsilon cap is equal to y minus y cap, y minus y cap, and that is also you require to find out. So if this is the case, what you require to do, so your y variable is y1 y2, so 10 12 and 11, and y2 is 100 110 and 105. So what you require to do now, you require to find out what will be the y cap values. Okay. Now y cap values is, y cap is x beta cap. Now x is 1 1 1, then if I go to the data set, original data set, that is 9 8 7, then 62 62 58 and 64. So this one is 3 cross 3, then what is your beta? Beta cap we found out, I think that 35.80, then your minus 0.80, minus 0.30, then 229, 4.00, minus, this is minus, this minus 1.50. So, this is your x beta. So, when you have written this x y equal to x beta plus epsilon, please keep in mind we are writing in terms of data matrix. So, here if it is n cross q, then it will be n cross p plus 1, then this one is p plus 1 cross your q, and this will be n cross q. So, that is why in the earlier format what we have written, that not in terms of equations, variable only equation, but from the observation point of view to write. So, this into this is also 3 cross 3. So, ultimately if you write down this one, what you will find out surprisingly that 10, this will be 12, this will be 11, this will be 100, 110, 105. So, what you are getting exactly same value of y. So, if I write here, then if I write here, then 10, then 12, 11, 100, 110, 105, what you are getting 0, 0, 0, 0, 0, 0. Why this is happening? Why this is happening? This is happening because if you recall the multiple regression case, there what we have seen, there we have seen that when r square equal to SS r by SST, and then we have written 1 minus SSE by SST, then we have written 1 minus your n minus p minus 1 into SE square by n minus 1 into SY square. You can remember this. Now, here in this case, if I think from the that parameter vectors point of view for everyone, for suppose if you go separately for y1 multiple regression, for y2 multiple regression, your estimate value remains same. As I told you that finally the error terms, there will be the difference. Here what is happening? What is the n? N is 3. We have taken 3 observation. What is p plus 1? 3. 2 plus 1, 3. So, then if I put here n minus p minus 1, that is 3 minus 3, this is becoming 0. So, your r square becoming 0, 1, r square will become 1 when epsilon that will be 0, the error will be 0, completely 0. So, we should not be happy with under such condition. This is an indication that your model is not at all fit model, although we say r square 1 means perfectly, this is a saturated model. What is saturated model? The number of observation is equal to the number of parameters to be estimated. So, saturated model case always you will get the perfect fit, that for but for regression purpose this is not desirable. Okay. So, once you have developed this, that your equation is ready,